Gentlemen, so today what I want to do is review every single thing we've done so far in chapter 2 and put it all together. So as a quick review here, here's my triangle. What do we call the longest side? Right, hypotenuse. Write this in. The side across from this angle is called the opposite. And then the last side, of course, is the adjacent. Okay? What I also like you to do now is see if you can write out the definitions for those three trig ratios. Sine, cosine, and tangent, please. So over here I said sine of angle A, or I'll say theta. I'll call this A down here. So sine is equal to what divided by what? Opposite. Okay, I'm going to write that in short form this time. I'll say opposite is OPP over the hypotenuse. Okay, HYP. And this is the short form because I'm getting lazy. Cosine of angle A is equal to adjacent ADJ over hypotenuse HYP. And the tangent of A is equal to opposite OPP divided by adjacent ADJ. Now, ladies and gentlemen, you need to memorize this. Okay? Memorize. Would you like to know an easy way of memorizing this? Yes? Okay. In this little bubble here, I'm going to draw a mathematical picture for you. Okay? A picture helps you memorize things. All right? I want you to draw this in as well. It's a very, very complicated picture, though. Okay? Here we go. I want you to draw two parallel lines, one of them longer than the other, like this. Okay? Draw two parallel lines. Seriously, draw this in. Okay? Then I'd like you to connect them together to make what we call a trapezoid. Okay, this is like a trapezoid. All right. Now, there's something called the sine curve. Like sine, the function sine has a curve. It's a graph. You'll learn this in grade 12. I'm just quickly going to show it to you. It looks like this. Okay, so draw this in. It's up and down, up and down, up and down, up and down. So do something like that. Okay. So this is a sine curve. Maybe if you don't want to make it that big, you can make it a little bit flatter. It's up to you. Okay, so just draw some sort of curve like this. All right. Now, here's the next thing I want you to draw. Okay. Now watch me first, and then I want you to draw. Okay. This is a curve. I'm going to draw a curve. It looks like this. Okay. Goes down, comes like this, goes in, 1, 2, 3, 4, 5, comes back up like that. Okay? And then I want you to draw this as well. Sizzle, sizzle, sizzle. Seriously, draw that in right now. What are you laughing for? Draw this in. Okay? Draw it in. Okay?
Why is it parallel?
All right, now, what do you see in this picture? Foot?
A toe.
Foot? Not just a foot, but more importantly, what's this little thing called here? A toe. Okay, what are we doing with this toe?
We're soaking in water.
Soaking it in water. Okay. So, what I'd like you to understand is this. All right? To help you memorize, I said, let's do this catchy phrase. Now, where does this catchy phrase come from? Let's take a look at the letters, the first letters of everything, okay? S, O, and H. So I'd like you to write this down. S, O, H. Okay? And then you have C for cosine, right? C, A, and H. So the next thing is C, A, H. And then the last part, the tangent, is T, with the O and the A. T, O, A. What does this say? Sohcahtoa. And then the sizzle is the ah. Okay? So, here's what I'd like you to understand. All right? This graph or picture represents so, meaning you're soaking your toe. Right? Sohcahtoa. And then the last A is the ah. You're so good. So my advice to you is this, okay? Either remember the picture, better yet, remember the saying of Sohcahtoa. Okay? Sohcahtoa. This is how you can memorize sine is equal to opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals to opposite over adjacent. Pretty neat?
Yeah, that's one of the
Sohcahtoa. I will not ask you to draw this picture on a test, but you should know this saying for sure. Okay? Sohcahtoa. All right, so with this idea of Sohcahtoa, right, we're going to learn today how to put all this stuff together. And to do so, one of the first things I want to show you is how to what we call solve a right triangle. When I say solve, this is what I mean. Solving a right triangle means finding all the unknown sides and all the unknown angles. Okay? So let's take a look at what we can do underneath. It says a triangle can be solved if one of the two following scenarios is given. So you'll see questions like this, where I give you two sides of a right triangle and you have to find the rest. Or I'll give you the side of one and one of the acute angles and you have to find the rest. Okay? Now, can I just ask you one thing here, please? When you're doing these questions, I'm going to ask you to not round until the end, okay? It's a little bit nicer if you want to have more accurate answers to not round until the end. Okay, let's take a look at some of these examples, okay? Example number one. This is the question where I give you two sides, so that's like this first scenario. Let's take a look. It says, side BC is 30, side AC is 17, and angle A is 90. Solve the triangle. Well, first of all, let's draw the triangle. Okay? So I'm going to ask you always to draw a right angle triangle. Okay, so please draw this in. Okay? And then I want you to label the sides for me. Before we do that, let's label the vertices. Angle A is 90, so this must be A down here because it's a 90-degree angle. B and C, it doesn't really matter which one's which. I'll put B up here, I'll put C down there. Okay? Now, what other information does the question show us here? The hypotenuse is equal to what number? 30. See, but BC is 30, so that means side BC here is 30. Awesome. How about AC? That seems to be 17, so AC is the vertical or the horizontal one? Which one? AC is the horizontal, sure. So let's write down 17. Okay. The question says, solve the triangle. Meaning, find all the missing sides and find all the missing angles. There's lots of different ways you can do this. Can someone suggest me what I should do first? Lots of choices. Find the angle I heard. Which angle? Angle B or angle C? Which one? It doesn't matter, but we'll say C? Okay, sure. So one possible solution now is let's go ahead and find angle C first. Good. Let's find angle C. Huh. Okay. Finding angle C. So here's my angle. What are the names for those sides again that I know? 30 is equal to what name? Starts with a... Okay, good. Hypotenuse. Yep. What's the 17 then? Adjacent. Good. Okay. A and H. Sohcahtoa. Ka, which means it's cosine. So can you see how the adjacent and the hypotenuse mean we should use cosine? Right? This is the Sohcahtoa. It's the ka part of the toa, or Sohcahtoa. So cosine theta equals to 17 over 30. Can you solve this, please? I hope so. Bring out your calculator, and I'll bring out mine. Make sure your calculator is in degree mode, okay? I gotta tell you, right after their test, some grade 12 came to me and said, and she was crying, Mr. Lee, Mr. Lee, Mr. Lee, I failed my physics test. I'm like, physics? Why do I care? And she's like, well, because we were doing angles and cosine and sine. And guess what? Her calculator was in the wrong mode. She did the whole test in the wrong mode. She got 8 out of 23. Yes, even though she knew how to do every single thing right. So make sure your calculator is in degree mode, and please go ahead now and find the angle. Second function cosine, 17 over 30, and I'll say it's 55.48. Okay. And once again, I'm not going to round too much yet, but I'm going to say 55.48 degrees. And that's the angle C, right? This is angle C. Angle C. Good. But we're not done. We got to find everything else. What's the next thing you'd like to try to find here? The what? The side opposite? Sure, okay, so Jillian said, let's go ahead and find the side AB. Okay. Now, you can do this many ways too. So, can someone give me a suggestion of what they want to do here to find side AB? Sin, I heard. Okay. So, now someone said, well, because AB, I'll call this X here, this seems to be the opposite side. Since I have opposite and hypotenuse, I'm going to use sin. Sure. So what do we have here? It'll be sin, and the sin of what number? What's the angle? Uh-oh. What's the angle we're using? Yeah, the angle down here, which is 55.48. Good. So let's use our answer from before. 55.48 equals to opposite, which is x divided by hypotenuse, 30. Good. Go ahead and solve this again then, please. Right, we have here over 1. We cross multiply. 30 times sine of 55.48 equals to 1 times x. Bring out your calculator. 30 times sine of 55.48. That equals to 24.72. So I'll say x equals to 24.72 centimeters. Done. And that's the length of AB. Are we done? Oh, still not done. These questions take forever, you're thinking in your head. Right, Ray? Uh-huh. So what's the last thing I need to do now? Find the angle. Find the last missing angle. The last missing angle is angle B. How can I find angle B? Yes, Dina?
Well, since like all the angles in the triangle add up to 180, add like 50.
You bet. You can use this fact that all the angles in a triangle add to 180. So by knowing the other two, you should easily be able to find the third. So angle B probably equals to 180, subtract off 90, and then I'll also subtract off the 55.48. So what do we have? That would be 180 minus 90 minus 55.48 equals to, I think, 34.52. Okay, and then this is angle B. I think it's 34th of a month. Double check your calculations. Okay? Now, ladies and gentlemen, before I go on to the next example, this is just one way of doing it. Okay? You didn't have to find AB using sine. What else could you have used to find AB? Tangent, I heard, yeah. Opposite over adjacent. You could use tangent too. What else could you have done to find the side AB? I heard Pythagoras, yeah. Knowing two sides of the right triangle, you can use Pythagoras too. Yeah, you bet. To find angle B, did you have to use this idea of all angles in a triangle add to 180? No, you could have used something else, right? You could have made that the angle. You could have made that hypotenuse, that opposite, changed it around, and used the trig ratios as well. There are many different ways to solve these ones, okay? All right. So I just showed you one way. There are multiple ways of doing it, but your answer will always be the same. Okay, I'd like you to turn the page now, please. And before I show you my method, I would like you to try this one on your own or as a group. Okay, I'll get Angie to come around and help you out as well. But this is a question where I gave you one angle and one side. And when I say solve the triangle, I want you to find all the missing parts. Okay, so I want you to find angle C. I want you to find side AB. And I also want you to find side BC. It doesn't matter which one you do first, as long as you get them all in the end. So I'm going to give you a few minutes right now to try this. Okay? So try this right now first, and then we'll come back and discuss in a few seconds. Which would you like me to do first? Find angle C, AB. Which one? Find angle C? Okay. Find BC. Oh, I'm confused. But no, you know what? All the ways work. So let me go ahead and find BC first, just for fun. Okay? I'll find BC first. How would I find BC then? If BC is this, how would I label my triangle? What's 26? That's the hypotenuse. What's x? Opposite. Good. So what ratio should I use? If it's opposite, hypotenuse, OH, that's Sohcahtoa, the so part, so it's sin. So I write down sin or sine 51 degrees equals to x over 26. Okay, that's what you should write down first. Now to solve for x, what do? I'll cross multiply, so 26 times sine 51 equals to 1 times x. And this is where you go to your calculator now. Yes, you do need a calculator. Okay, 26 times sine of 51. Oops, I forgot the sine button. And what's the answer here? About 20.2? Yes or no? Yes, okay, good. Okay. Then I heard some people shout, go find angle C, go find angle C. Okay, I'll find angle C. How could you find angle C? The 180 minus. Now, if you didn't like that 180 minus, you could have also set up a ratio here and used like opposite, hypotenuse, all that kind of stuff too. But I like the idea of angles in a triangle adding up to 180, which I think is pretty straightforward. So 180 take away 90 is 90, take away 51 is 39. Good. Angle C is 39. And what's left over for me to figure out? AB. So how can I find out AB? Any suggestions? There's lots of ways. Cosine, I said. Okay, well, cosine of what, though? What numbers? Okay, now 39 is this angle down here, right? So you're saying to find AB, I should use cosine? Okay, now, once again, you have to be careful because if, depending on which angle you use, the opposite and adjacents are different. If I were to use 39, okay, then the side over here is called the opposite, and this side down here, which was x, is now called the adjacent. Now, of course, the hypotenuse still stays as is, all right? So if you were using 39, that's great. Now, which ratio would you like me to use? Okay, I can use tangent. I could actually use cosine. I could probably actually use... Actually, I can't use cosine. I have to use either tangent or sine. So let's use tangent. Sure. Tangent 39 equals to opposite, which is the y value. X, which is my adjacent, is the number 20.2. So if you set up a ratio like this using tangent, go ahead, once again, cross multiply and solve. And let's see what your final answer is going to be. So y equals to 20.2 times tangent 39. Go to your calculator, 20.2 times tan 39. And look at this, about 16.4. Yes or no? Now, ladies and gentlemen, if you didn't do it my way, you should have still got the same answers because the triangle hasn't changed. So please double check that you have these three numbers, and if you do, give yourself a pat on the back. Give yourself one. Okay. Ladies and gentlemen, you try number 3. Number 3, guess what? No picture. You draw your own picture. Okay, so I'll give you a few seconds to think about that as well, and then I'll give you the answer. And then we'll try the next ones, the word problems. Getting fun now. Shh, quiet please. Okay, BCD. Now, even drawing the triangles could be different, okay? I mean, I could draw the triangle like this, BCD. You could switch this around. It doesn't really matter. In the end, it'll be the same. Angle C is 90. Angle B is 31. So I'm thinking right now I can automatically solve angle D. 180, take away 90, take away 31. I heard people say 59. Yes? Okay, so angle D is 59. We also have here BC equals to 10. So there we go. What else do I need to solve? I need to solve for either CD or also BD. So let me call CD X, let me call BD Y. Doesn't matter, once again, what you call it, what you do first. I don't care. Let's find CD first. Now, you have lots of choices. Okay, lots of choices as to how you find CD. I'm going to use this angle up here, 31. And if I'm using 31 as my reference, x is equivalent to what side? Is it the opposite, the adjacent, or the hypotenuse? In my picture now, what would it be? Opposite, right? Across from angle 31. What about the 10? What would we call that? Adjacent. Good. Opposite and adjacent. O and A. Which trig ratio should I use? Sohcahtoa says use tangent. Right. So tangent of theta. Now I know what theta is. It's the number 31. So tangent 31 equals to opposite, which is x, divided by adjacent, which is 10. So if I want to solve for x in this case, x equals to 10 times tan 31. And I'll bring out my calculator. 10 times tan 31 is equal to 6. Did you guys all get 6 for CD? Good. 6 meters, please. Put your measurements. Now, how about BD now? How can I find BD? Well, once again, it's up to you what you want to use. You can use the ratios. You can use the different angles. You can also use Pythagoras. I'm just going to use Pythagoras for fun, okay? Because I haven't done that yet with you. So let me try to find BD using Pythagoras. Here's 10, here's 6. I guess here's BD. So I'm going to use Pythagoras, okay? So for some of you who use the trig, that's fine. But I'm just going to use Pythagoras to try this out. 10 squared plus 6 squared equals to y squared. 10 squared is 100. 6 squared is 36. So y squared equals to 136. So when I solve for y, I take the square root. And what do I get? I hope it's the same as what you have. How about 11.67 or 66? Yes or no? Okay. So once again, dear friends, you have many different ways you can solve these questions. You don't have to follow my way. Your ways will work. Just make sure you are clear and you are concise. Yes, Oksana. Yeah, now don't worry too much about the rounding. I'm not going to be that picky. Okay, I'm looking for if you can actually understand how to do this. So if you're a little bit off, like a 0.1 or something, that's okay. All right? Okay, let's try the next question on example number 4. Now it gets really, really interesting. Okay. Ladies and gentlemen, have you seen windows like this before in this shape? Okay, this is a regular decagon. By the way, how many sides does a decagon have? Katrina? 10. Deca is 10. Good. Okay. Now, it says the distance from one vertex to the opposite vertex. This is what I mean. Here's one vertex or one corner, and the opposite corner is probably this one down here. Okay, right opposite of it. So I'm saying the distance from one vertex to the opposite measured through the center, so it goes through the center, is 16 inches. The question here says determine the length of the wood molding material that forms the frame of this window. So bottom line, I want you to find this, plus this, plus this, plus this, plus this, plus this. Add them up. Now, because this is a regular decagon, what do you know about each of these little things I highlighted in yellow? They're all equal. Good. So bottom line, all you need to do is find out one of these pieces and then multiply your answer by 10. Good. But the question is, how do I find the length of one of these pieces? Divide into triangles. Okay. Divide into triangles. How about this triangle here? Okay. Now, let me just think about this. How many triangles do you actually get if I do it this way? Oh yeah, you should get 10 of them. Okay, you don't have to draw in all 10, but I'm just showing you the 10 triangles. JC. Okay. Okay, we have triangles. Good. Do we know any angles? Do we know any length of the sides? Because if we don't know those, we're in trouble. Katrina? Yeah. Up to you. What do you want to tell me? The angle here, Katrina says, is 36 degrees. Why? Yes, Katrina, give me more. Do you remember, dear friends, that in a circle, if I go around the circle or if I go around a point, how many degrees are there? It's a whole 360. So keep going, Katrina. And because there are 10 triangles, Katrina says, we should divide that number by 10. So correct. All we did, or all Katrina did, was take 360 divided by 10. That gives you the answer 36 degrees. Nice. Now, someone else. Can someone else tell me, Can someone else tell me something about the sides? Do we know any of the side lengths here? Jillian says they're 8. Why? That's right. They go to the center, the half of 16. So each of these blue lines is equal to 8. Cool. Your job was to figure out the length of this long side here that I highlighted in blue, green, yellow. Okay? So let me just try to maybe redraw this triangle for you so you can see it better. 8, 8, and the whole thing here is 36. How can I find the length of this side over here? Stella, sure. Divide the triangle in half? Oh, remember we need right triangles. That's great. So let's divide the triangle in half. I like that. Now if I divide the triangle in half, can you see now how this red triangle is a right triangle? No? Now, in addition to dividing it by half, I guess this angle here also is cut in half. So what's this angle in red going to be now? How much? 18. Awesome. I like this. Ultimately, you want to figure out the length of the question mark. But with your red triangle, you can only figure out half of the length of the question mark. That's good enough for me, at least for now. So how can we figure out this length here? Let's call this length x. Can someone give me a suggestion? I've got the 18 degrees. I've got the x. I've got the 8. Which ratio should I use? I heard 10. Okay, let's think. 18 degrees, so this is the opposite side. I like that. What's the 8? That's adjacent? That's hype. Yes, remember, it's always across from the 90-degree angle. That's hypotenuse. Opposite, hype. The ratio to use is sine. Good. Sine 18 equals to opposite over hypotenuse. Go ahead and solve for x, please. Okay. We'll cross multiply. 8 times sine 18. Okay. Keep going, please. 8 times sine 18. 2.5? Okay. Let's go 2.47. I'll do 2 decimal places for now. 2.47. That's x. Good. But remember, I wanted to find out that length in blue here with the big question mark. So what's the actual length in blue? What's this going to be over here? It's not just 2.47, but I have to double it. So times that by 2, what do we get? 4 point. Good, 4.94. That's still not done yet, right? Because my question said determine the length of the wood molding around the whole decagon. So the length of the wood molding would be equal to what now? The length of the wood molding would be that 4.94 times by, and I heard it, 10, because there are 10 sides. So I believe the answer is 49.4, and this is in inches. There you go. See how I tried to apply trigonometry to different things? Okay. Yes, Suleiman. Question.
For dividing the
I could not use Pythagoras here because I don't have that right angle. You see, Suleiman, if you did not divide the triangle in half, if you kept the blue one, where's your right angle? It's not there. And when I don't have a right angle, I can't use Sohcahtoa, I can't use Pythagoras, I am in trouble. Okay? Until you take grade 11, and then you can do it. Okay, let me give you a hint to number 5, and I'll let you try this one on your own to try to figure this out, okay? You know these words perimeter and area quite well, but you might not know what this thing is, an isosceles trapezoid. Let me draw it for you, okay? 2 parallel lines, it's kind of like that water tub. And then you connect them together like this, okay? An isosceles trapezoid means these 2 lines are parallel, and then the 2 slanted sides are the same length. In this picture, or in this question, it says the shorter side of the parallel sides has length 12, so this is 12. And the height, which is this, is 4.6. And it also says that the base angles measure 55 degrees. So this base angle down here is 55. This base angle over here is also 55. Okay? Now, the question says determine the perimeter and then the area. Let's do perimeter first. What's the perimeter again? The distance around the entire object. So maybe what you need to do is find the length of this and this. They're the same. You already have the 12, which is great. And then you probably need to find the length of this thing down here. Not easy, but yet doable with trigonometry. Once again, I'm going to get you started. But remember Sohcahtoa. And the key thing here is you need to create or find the right triangles. So see if you can create that. And from there, you should be able to. Not too sure what to do. Let me give you a bigger hint now. Remember I said look for the right angle triangle. So I'm going to draw it a little bit bigger for you. 4.6, 55. Here's that side that's yellow. Here's the side that is purple. Okay, at least part of the purple side. Gentlemen, let's focus here, okay? Now, let's see if you can figure out the length of that slanted side first. Let's call that x. And I heard someone say, well, Mr. Lee, I've got 55 degrees. I've got the 4.6, which represents the opposite side. The x, which is the longest side. So which ratio should I use? Sin. Good. Sin of 55 degrees, please, equals to opposite 4.6 over hypotenuse. Now, this is the one where it's a little bit tricky because your x or your variable is in the denominator. So you can still do cross multiply if you wish. That becomes x times sine 55 equals to 4.6. But then to solve for x, you need to now divide. So take 4.6 divided by sine 55. I like that. So what's that on the calculator? 4.6 divided by sine 55. The answer is 5.6, and I'll say 5.62. Good. Now, that's that yellow side. What about the purple thing then? Let's figure out that purple piece as well. Can we? What do we use, Patrick? Patrick says, oh, let's use tangent now. Okay. Because we know this is 5.62. Well, we don't even need that, right, for tangent. You're right. Opposite, this is what they call the adjacent side. So let's go ahead and figure out the purple side here. I'll call that y. So therefore, what do we have? Tangent of 55 equals to opposite 4.6 divided by the adjacent, which is y. Okay. Find the angle? You could find the angle on the top, but we don't need it, I don't think, because you're just looking for the lengths right now. We'll cross multiply. We'll get y times tangent 55 equals to 1 times 4.6. And then we'll solve for y by taking the 4.6 and divide that by tangent 55. Okay? Calculator time, 4.6 times tan, or divide by tan 55. 3.22 is what I got for y. Now, ladies and gentlemen, this is a very good start. Now, can someone tell me how I should find the perimeter then? Well, we know that the yellow stuff is now 5.62. What's that big long piece in purple in my regional isosceles trapezoid? What is the length of this whole thing here going to be equal to? Well, what's this little piece from here to here? How much is that? How much is this piece right here? 4 point, what?
3.2.
Oh, 3.22, good. So that's 3.22, right. Now, what about if I cut this in half here? So what's this part from here to here? That's also 3.22. What's left over in the middle? 12. Let's add them up. And that gives you the longest side. So 12 plus 3.22, 15.22 plus 3.22, 18.44. Is that correct?
Yeah.
I did it in my head. Are you impressed?
No.
No? Oh. You're supposed to be. Okay, so the longest side is 18.44. Can someone now calculate the perimeter for me? 18.44 plus, now what's that yellow side? 5.62 plus 12 plus 5.62. So what do we have here when we do that? This I can't do in my head. Is it 41 something? 41.68. Good. Centimeters. Good. All right. And then remember how to find the area too. I did this in chapter 1 with you. Do you remember? Area. I would actually ask you to split this up into 3 shapes. You've got the 2 triangles plus the actual rectangle. Remember that? I'll let you try that out, please, on your own, okay? See if you can do that, please. Okay. So think about the base. So it's 3.22. The height is 4.6. 4.6 and 12, I believe. Okay. Please don't pop your gum. Okay. How do you find the area of a triangle? Base times height divided by 2. Thank you. 3.22 times 4.6 divided by 2. Area of a rectangle is just base times height, so 12 times 4.6. And then once again, you have another triangle that's the exact same thing. So go ahead and calculate all these, and you'll get your final answer. 3.22, oops. 3.22 times 4.6 divided by 2. How about 7.406? 12 times 4.6, what's that? 55.2. And this is another 7.406. So add this all up, and there's your area of the isosceles trapezoid. How about a whopping 70.012? Agree, Brian? Centimeters, what are my units? Centimeters squared. Cool. Ladies and gentlemen, let's stop for today here, okay?